In our previous session, we have studied about the chemical changes and some of the chemical reactions. Now in this session, we are going to study about chemical reactions. Some of them are neutralization reaction, rusting, and displacement reaction. Here we are going to understand about each of them in detail. After which, we are going to know about the reactivity series. Share screen. The most important chemical reaction which we are going to study today is neutralization reaction. What is neutralization reaction? It is a reaction in which an acid and a base react to form salt and water. It is called as neutralization reaction. So here, as acid plus base gives salt and water. This is what is neutralization reaction. The literal meaning of the word neutralization is an action intended to nullify the effects of some of the previous actions. In chemistry, it means a reaction between an acid and base, which results in formation of salts. Now, neutralization reactions play a key role in functioning of our body. For example, all of you are knowing that our stomach contains hydrochloric acid, which is used for digestion of food. Sometimes these acids become too much for our stomach to handle. That time we get something called as acidity. Now doctors give us antacids to treat acidity. Most of the antacids are nothing but weak bases, and these weak bases, when reacts with acid, nullify the effects of acid and form salts plus water and carbon dioxide. So antacids mainly contain magnesium hydroxide or milk. Most of the antacids contains milk of magnesia, and they contain magnesium hydroxide, that is called as milk of magnesia. They even contain aluminum hydroxide, sodium bicarbonate, calcium carbonate. So all these are bases. And when antacid, that is weak base, reacts with our stomach acid, that is again hydrochloric acid, there forms salts, water plus carbon dioxide. So this is example of neutralization reaction. Another reaction is between vinegar and baking soda. So I'm going to show you about the neutralization reaction in detail in this further video.
Let us do an activity to understand neutralization reaction. Materials needed are a piece of chalk, vinegar and a test tube. Drop some crushed chalk in the test tube. Add vinegar to the test tube. Watch what happens. The chalk reacts with the vinegar. As the chalk reacts, the bubbles of carbon dioxide comes out. A white solid is formed on the plate, which is calcium acetate. Chalk is calcium carbonate. Vinegar is acetic acid in water. When they react, carbon dioxide, water and calcium acetate are formed. Thus, we can say that an acid reacts with a base to form salt.
You saw that there was carbon dioxide which was formed and chalk was nothing but basic, right? So here, whatever carbon dioxide formed can be taken in a separate, evolved during the reaction, can be passed through lime water and it turns it milky. Even this indicates that there is presence of carbon dioxide. Now let us read or study about the other reaction, that is rusting of iron. Now, what is this rusting of iron? Let us study. Rusting of iron is an undesirable change. You might have observed that during rusting, when the iron rusts, because iron is used for construction purpose, so when the iron rusts, it is an undesirable change. Over the years, scientists have studied many things where they have noticed that iron rust when there is presence of moisture and air. So we are going to study about rusting. That is, here in the experiment, I'll show you. I've taken up an activity which is even described in your textbook, where to observe that iron rusts only in presence of air and water. The rusted iron is called as iron oxide. So iron in presence of water and oxygen gives iron oxide, that is nothing chemically called as the rust. The chemical name is iron oxide, which is nothing but rust. So let me show you this experiment. Okay.
The aim of this activity is to observe that iron rusts only in presence of air and water. Here we have taken 3 test tubes A, B and C. In the first test tube A, we have taken unrusted nails to which we will be adding calcium chloride. So we have added calcium chloride and I am going to put the rubber stoppers. In the next test tube B, I am going to add boiled water on which we will be adding oil so that there is no contact of air done. So here I am adding boiled water. On top of which I am going to add oil. And in third test tube, I am going to add simply water, that too boiled water. Now, according to after these 3 test tubes are being placed, they should be kept for few days. Observation that should come that in the test tube A and B, the nails do not rust, and in test tube C, it rusts. The reason would be that in the test tube A and B, in test tube A, as you can see, there is no presence of water. Whatever water moisture is there, that would be absorbed by calcium chloride, and hence there is no presence of water here, even though there is presence of air. In the next test tube, as the oil would be floating on top, which will avoid the presence of air, right? So hence even these will not rust, because even though there is presence of water, there is no presence of air. So nails in this test tube will not rust, and the nails in this test tube C will rust because there is even presence of air and water. So we'll see, I'm keeping it for 3 days and we'll see it on the 3rd day, and it should come that the nails in test tube C are going to rust.
So after the 3 days of experiment, now you can see the result here. I have clicked a photo of that, and you can see test tube A. In test tube A, the nails are not rusted. In B also, the nails are not rusted, and only in test tube C, the nails have rusted. So the aim of the experiment fulfills here, which shows that air and moisture are needed for rusting of iron. Okay. Now, how to prevent rusting? Now, there are methods of preventing rust. Okay, so you might have seen many a times before rainy season starts. Yeah, we try to apply paint and grease on our gates and iron gates. So these are all some of the examples where we are trying to avoid the process of rusting. So let us first see what are the different ways of rusting. So first way can be we call it as galvanization. And what is galvanization? It is the coating iron surface with another metal, that is zinc, and this is known as galvanization. Next is we can apply oil, grease or paint, as I said, to the areas which are made up of iron. Okay, so example, gates. Even some of the vehicles, the parts of the vehicles which are prone or exposed to the air and moisture are coated with grease or oil. Next is called as alloying. What is alloying here? It is again a method of rusting where iron is mixed with other metals or non-metals to form alloys. Mixing will help us to reduce rusting, of course. Now, stainless steel, which is again a mixture of the so many elements along with ions. That is, iron mixed with chromium, nickel, manganese, and carbon makes stainless steel. So these are some of the methods to prevent rusting. Now we are going to see about the next reaction, that is displacement reaction. And we are going to see even about reactivity series. What is displacement reaction? The reaction, the name itself suggests displacing, that is moving, right? So in this reaction, you will come to know that a more reactive element displaces a less reactive element from its solution. And this kind of reaction is known as displacement reaction. Now I'll show you a experiment where we have done there, where in a copper sulfate solution, how when we add iron fillings, the iron being more chemically reactive displaces the copper and there is change in the color of the solution. So let us see the video.
The aim of the activity is to show the reaction between iron fillings and copper sulfate solution. In the test tube, you can see there is copper sulfate solution being kept. To this, we are going to add iron fillings. Once the iron fillings are being added, you will see that there is, after some times you will observe that there is change in the color of the solution and even the iron fillings. So I'm just going to stir. Now, can you see that there is slight change in the color of the solution? The color of blue copper sulfate solution is turning towards greenish color, and even the iron fillings you can see here have changed into brown color. So this indicates that there is a reaction taking place. So can you observe here, students, there is change in the color of the copper sulfate solution and even the iron fillings, they are brown in color. Now the reason behind this is if a reactive element comes in contact with compound of less reactive element, a chemical reaction is taking place. So here the less reactive element is removed from the compound and replaced by the more reactive element. So this is called as a displacement reaction. In this reaction, the copper sulfate plus iron is reacting. So the iron has displaced the less reactive element, that is copper, and there is formation of iron sulfate, that is green in color. So can you see this? And this type of reactions are called as displacement reaction. Thank you.
Now, as we have seen the displacement reaction, let us now see why did it happen. So in displacement reaction, you saw that copper sulfate solution, which was blue in color, later turned to green in color. So that iron displaced the copper here. Now the reaction, now there are many elements which are kept in a table. Okay, it's a series of, so it's a series where it's a table where you will see that there are arrangement of metals being done on basis of their reactivity. That is, the more reactive metal is always at the top, and from there comes the less reactive or the least reactive metals comes towards the down of the series. So there is, you can see in this presentation as well, potassium is most reactive element, hence at the top, and the least reactive is platinum. That is at the bottom of the reactivity series. So this, you can see here iron, again it has displaced copper, right? So iron was, can you see here, iron being at the top in the reactivity series displaced the copper, right? So in this session, we studied about the displacement reaction, we studied about reactivity series, right? I hope students you have understood this. Thank you. Now student, just to summarize the entire chapter. So what we studied in this chapter, wasn't it interesting with all the experiments, right? And you came to know about many new things, isn't it? So first we studied about the types of changes. We studied about the physical changes. We studied about crystallization, which was again a new example for you all, right? Which was a physical change. Then we studied about certain chemical changes. We even studied different types of chemical reactions, certain various types of reactions we studied the neutralization reaction, displacement reaction, rusting. So we even studied about the reactivity series. So please go through the chapter, and thank you students. Thank you one and all.